This is what we're now working with. Listen, there's primarily four conic sections, and I'll show you a video, I swear, at some point. I just can't find the 15 minutes, but maybe I'll find the short version. But there are four conic sections. There's parabolas, circles, ellipses, and hyperbolas. And um, the video will make sense of why we call them conic sections. But the second one in the list is ellipses. And this today is going to kind of do ellipses. And we'll do this today and tomorrow, and honestly, probably into Monday. This is a big one. And this kind of includes circles. So I wanted to show you circles real quick, and then we won't do like an assignment on circles because they're just really easy. And then we'll kind of transition that over into ellipses. So this is what an ellipse looks like. It's like an oval. And this is what it would have been. And let me show you a circle. So you see all the fancy stuff in there, like the -4 and the -3 and the over 9 and all that stuff. If I just take this out, and let me get rid of this graph here for a second. So if I just did like x squared plus y squared equals 25, what do you see? A circle, more specifically, a circle with a radius of what? Tell me that you remember your vocabulary from geometry. What's the radius of a circle? The radius is from the center to any point on the circle. So 5 in this case, right? You okay? Can you see that? So if I wanted the circle to is it because they're too small to see? Sorry, I can't make them bigger. I've emailed them before and it's not possible. So if I wanted the circle to get smaller, I could make this like a 9. What's the radius going to be? Well, 3. And so that's just just a simple formula for a circle. X squared plus y squared equals r squared, right? What happens? What would I put over here if I wanted the radius to be 4? 16. I'd put 16, and then you got a circle with a radius of 4. And then finally, if I want the circle to move, that's where the h and k come into play. And you've seen h and k in very recent memory. So like if I wanted the circle to move to the right 2, what do you think I would put as my x modifier? -2. Good. So you remember that from our experience with this, that our translation sidewaysy, uppy, downy things, they tend to be a little like weird, right? So like if I did x -2 squared, then you'll notice that the circle has now physically moved itself 2 units to the right. And the y is also a backwards one. So like if I wanted the circle to go down 4, what would I change my y to? I would do y plus 4, right? So if I put in quantity y plus 4, then I can see, and so you see the translations or the transformations happening. So the circle physically went to the right 2 and down 4, and has a radius of 4. That's circles in a nutshell. Are you okay with that? I mean, that's it. That's all there is to circles. They're super simple. Ellipses are not super simple. So what happens now with ellipses, if I take this, and there's a lot here. I made myself a mental note earlier. Next year, when I teach this class again, I'm going to set aside a month for conic sections, at least, maybe 6 weeks. You guys won't get that. But if you take an equation like this and you restructure it like this, you change it from a circle to an ellipse. And what happened was a couple things. First off, I have it equal to 1, and that's going to come back to just the standard form equation. It needs to be there. Um, but you'll notice that it's got stretched, right? And so that's not supposed to make a ton of sense as to why exactly that happened. I just want you to see that it's really just a circle formula that got modified. When you start doinking around with your x squared, if you divide it by something, and your y squared and you divide it by something, what you're doing is you're now starting to stretch the graph horizontally and vertically, and that's what causes a circle to become more specifically an ellipse. Okay? So the goal for the day is, and I don't think I don't know. Did I ever hit record? Oh, good, I did. Um, Let me see. Let me just go back to the desktop here. Is this open? Let me just see if I have it. Oh, I do have it. I'm going to open this and just show you kind of what where we're headed towards. So I'm going to erase all this in a minute, but this is the goal for the day is to, here it is in a nutshell, is to get you to look at the equation of an ellipse and you're going to do seven things. Technically eight, but the seven things are you're going to find the center, easy. You're going to find the length of the minor axis, the length of the major axis. You're going to find the vertices, the co-vertices, the focal length, and the foci. And before that can make any sense, you have to understand sort of what all the lingo is about. So I'm going to head over to Desmos and I'm going to graph the one on my note card. And you'll probably want to be playing around on Desmos over the next few days because what I find is it helps us to verify things. Like it's fun, maybe not fun, but gratifying to do an ellipse problem. And then when you think you found like the co-vertices to actually see it with your own eyes or to estimate where the foci are at. And all that vocab will make more sense here in a couple minutes. So anyways, this is the goal. This is where you're headed is to do this for every single problem. Okay. Right. So I'm going to head on. I don't know how you want to approach this. Do you want to approach it graphically first, or do you just want to see the algebra? You want to see a graph first? I'll do a graph. You don't care. Cooper, what'd you do with my note cards? Oh, well, let me hand this out first. By the way, I made this for you. I want you to know that this is, oh, I should pause it. This is going to help you a lot.